All right, well, we'll continue our discussion on machine learning. And today I want to speed up. Okay, I just want to cover one item. It's a very simple example, but I think it will tell you a lot of good ideas behind some of this large language model, generative AI. Obviously, we're not building a large model. We're building a very, very little tiny model. And the machine learning model we use behind it, even very naive, is not really the kind of advanced algorithm being used in in today's generative AI models. But I like the simple things because it really shows you the fundamental idea and the procedure to handle this kind of problems. And because in for the professional training model, it's already kind of a beyond our ability to really fully understand or to handle. So that's why I feel knowing the fundamentals, really the fundamentals, is very important. Okay, very quick recap. Okay, so last time we were talking about a classification. And before that, we're talking about the regression. Okay, so it's a two typical machine learning problems. Regression, we're dealing with continuous data. Okay, you can predict values. It doesn't have to be, uh, you know, showing in the training data set before. And then classification handles slightly different problem that we give you different categories, labels. Okay, and then you predict which one it is. So you have to choose from one of them. Okay. So let's come back to this language model we talked before, right? So if you remember, um, the first week we were talking about that all the ChatGPT is trying to do, okay, is that we provide a input data set, not data set, like input sentence, and the model take that input and try to predict the next word, the most likely word that's going to show up in sequence as the next word. Okay, so that's all they're trying to do. Okay, so if you really think about this one as a machine learning problem, we're making a prediction. And we actually briefly talked about this one. This is more of a classification problem. Okay, so there's so many words to choose, and you had to tell me one of them. And you're never going to tell me it's like 2.5, 3.5. You have to tell me it's a second word, third word, coming from one of the categories. Okay, so the language model training process is kind of like a classification problem. Okay, so let's just dive into an example. We're going to work on this example and to show you what is that process. Okay, so let's say I give you this kind of data set. Okay, I want you to learn from it. I want you to be able to predict some kind of word based on the given sentences like this. Okay, to make it very simple, I only provide five sentences. All right. And also, obviously, based on these five sentences, you can predict a lot of things. You can train a lot of different type of models. But let's also simplify this problem by just focusing on the last word from the sentence. Okay. So most of these are just nouns. Okay. So the first one is the books, and second one the jumps. Okay. And the next one the coffee, and after that the field and majors. Okay. So let's say that we just want to train a model. That if I gave you the full sentence, not full sentence, but the first part of a sentence, and you just tell me the next word, but the data set is like here. I just tell you what is the next word at the end word to be. Okay, so that's a little machine learning problem we're trying to do. Now, if you remember, I told you any kind of machine learning problem, you have to follow these steps. Okay, you have to understand that problem very well, define that problem. When we say we're defining the problem, we're trying to define the target column, the input columns. Okay, and then we provide data sample and we choose a model, train and predict. Now, in this case, start to think about how do we define the target and the input features. Okay. So the target is that the words at the end, we were trying to predict that one word. Okay, the single word at the end. And the input obviously is all this sentence or strings in front of the last word, right? So that's obviously the case. So if you think about it, that is our uh, problem. Okay. Always think about the table. So any machine learning problem, most of those you should be able to visualize that or structure that as a very nice clean table. Okay, you're trying to predict the next word, and then you have this input synthesis. Sorry, the input features. In this case, it's just a synthesis. All right. And just like the other examples we did in the past classes, okay, so then we write a code to do the input model, sorry, input data, output data, choose the model, train, feed, and then predict. That should work. Okay, so just looking at the data, the data set doesn't sound like very complicated, but there is a small issue here. Okay, because the one major difference between this machine learning problem and the previous one, like iris example, rock, paper, scissors example, and traffic example, is that those table, if you remember, they got a very clean, very organized, like columns filled up with all the numbers. Where in this case, you just have one thing. You have one column only, which you put all the things at the string at the sentence, and the sentence has all different type of you know, names, and then they have different number of words in the sentence, different number of strings in the sentence. So that actually brings a lot of variance. And this is something that machine learning model doesn't want to see. Whenever you use a machine learning model to train, they really want you to provide a very precise data structure. So for example, coming back to here, okay, I'm going to back to this SVM example. So going here, let me just run it very quick, just recap. Okay, so this is what we did before, that we provide input data, this iris flowers coming from the website. We have three types and we provide three targets. And then here, this is we're going to try to predict. And then we print the result, we print the one of these three types, which was very accurate based on what we saw last time. But then this time you can see output data, sorry, the target data is this, just one column. That's target, that's easy, which is the same as the language model we're talking about today. But the input data, we have four columns. If you remember, it's a petal length, width, and the settle length, width. So four things. As you provide the input, you have to give exactly the four input data or features or columns, exactly, right? So let's say if I go here, I miss one. I don't have that one. Okay, I missed the one column here for some reason. And if I try to run this again, this will not work because your input data isn't really fit into the input column because you're trying to let me to learn it. You tell me there are four columns or four features related with the target, but now you miss some of those. I don't want to risk or figure out how do I handle those. Okay. If you tell me there are four, you have to tell me four things. Even you give me some special value, you tell me it's a negative, that doesn't matter, but you have to provide that. So it's really important that you provide really the perfect set of input data for any kind of machine learning problem. And the same case here, when you try to predict, right? So if you don't give enough, or if you give extra, it will always make the model very confused. Okay, so this one, instead of giving four input, I give five. If I run this one, and it's still not gonna, give you anything. Okay, because then the model doesn't know what to handle because that's not how you ask the model to be trained, right? So we have to give precisely the input features, the right number of features, based on the problem you define, right? So that's why if you come back here. Okay, if you use this one just directly at the input data, first of all, the machine learning model really cannot handle the strings very well because it doesn't mean anything. And secondly, all these things obviously have a totally different lens. If you just throw all of this together into a model, that's not going to work. Okay, so let's actually try that. To let me make this one more clear. Okay, so if I'm following the same thing, okay, I'm gonna put the input data. Okay, so I'm gonna copy all of this. All right. Yeah, so they figure out everything for us. So make our job very easy. So I have this input data here. And also don't forget what we normally do is that we put them into another list, just in case that you have um, multiple dimensions. Okay. So all right. So that's our input data. Okay, I'll just still call it input data. And then I have my output data. So that's going to be the books and then jumps, coffee, and we got a field and a matrix. All right, so they predict we're going to use SVM. That's very cool. And this is good because they kind of learned the history from our previous examples. And all we need to do is import to get the SVM model. So I'll do this one. All right, so once again, import model, SVM, we talk about that's a very popular classification model to use. Okay, so, and then you give input data and output data, and here we're trying to make a prediction. Okay, so the input is we only provide the first part of a sentence, and then we're trying to get the answer. Okay, so I'm not gonna need that much. I'll just simplify it. All right. Let's try it to see if this one works. All right. See, very quickly, there's some error happened. If you look at the error message, is that I cannot convert the string into a float. Okay. So as they're processing the input data here, as you do the training, they don't take strings because SVM model, it is a, really behind it is a mathematical model. They use a lot of, I don't know, calculus probably to do the calculation. So they don't know how to handle the strings. So most of the machine learning model, I'll tell you, it doesn't handle the strings directly. Okay. So not to mention all the strings have totally different number of words or tokens. So this will make the problem a little bit more difficult. So as we process the language data, okay, the text data, typically you need to think about how do you encode those texts? How do you make some embeddings, turn those texts into numbers? Okay, because eventually all these algorithms and mathematics actually deals with some numbers most effectively. Okay, so now this you can see this time the problem is not about like choosing models or input data or input feature. It's all about how do we convert all the strings, the sentences into some kind of meaningful type of uh, input features that represented by numbers. Okay, so that's a new problem we haven't seen before. All right. So in other words, instead of seeing this one like this, we have to turn this into a bunch of numbers. Hopefully that number can represent all these words, right? But then if you think about this one, this isn't that easy to handle. Well, you can always say, okay, I'm going to give some encoding, for example, every word in the dictionary, right? So we give a number to represent it. I has some kind of number, love has some kind of number too, or you can say I have every letter, I use some number to represent it. So you can come with any approach you want, but eventually, don't forget, you also want to make sure that the columns are nicely aligned, so with the same number of columns. Okay, so so the first thing you have mastered today is how do you encoding, embedding all the text into the numbers. Okay, so this is not a new problem from the field called natural language processing. There has been a lot of work being done to do this type of things. Here, let me just show you a very, very simple way to do this kind of encoding. Okay, it's very simple, but it's so easy to understand. But once you understand this one, later on, if you think about any other kind of ways to encoding the text, um, the goal, the purpose is the same. It's just the algorithm is different. So this simple algorithm is called a count vectorizer. Since we call it a vectorizer because we're trying to, turn that whole thing into some kind of numbers. Okay. It's the process called like almost you think about like a multi-dimension vector, right? So they do everything based on count, okay? Based on how many times you have seen this word shown in this kind of a context. So here is example. So we have three sentences, and then this one is called this is good, this is bad, and this is awesome. Okay, three sentences. And then what they do is that they count how many times each word shows up in this whole data set. Okay, so for example, here, this is sorry, not just count first. Okay, first of all, they will build an index because in this data set, okay, you have a total of 1, 2, 3, 4, 5 different words you have ever seen. Okay, so you need to have an index to represent this word because we can't use string directly to represent. Number is much more efficient. So you give this at 0 at the index. Is 1 and 2 is good, bad is 3, awesome is 4, based on the sequence or the order you've seen these words. Okay, so that's the first thing, you build a little index. All right. Once you have this, and then you can just say that for each sentence, how many times this word has shown up in this sentence. So we look at example, it's going to be very clear. So the first row here represent the first input data, okay, which is this is good. Okay, so this shows up like a one time. So that's why this one here is 1. And then is shows up 1 time, so this is 1. And good shows up 1 time, so this is 1. And then bad and awesome, you don't see them in the first sentence, so they're 0. Okay. But then the position matters, right? So we talk about the first one, the index 0 represents this. That's why this one is this, right? And then the is the second one. All right. Based on this idea, pretty straightforward. This is bad, and then you can see this is bad. This one shows up 1, and the rest go to 0. Okay. But then if you have this is very, very bad, right? So if you have 2 words in a row or duplicates, some of those count will become 2. Okay, so this count here shows how many times you have seen that word in that one sentence. See, this approach is so nice because immediately you turn all these complicated strings, tokens into this perfectly aligned tables column with all the numbers, integers, which are really nice and preferred to handle over to the machine learning model to process. It's a very smart approach. This whole process is called a count vectorizer. Okay, it's coming from some of the natural language processing techniques. I don't know when this was created, but had to be a long, long time ago. Okay, nothing really new, pretty straightforward, easy to understand. Okay, so if you understand this one, then for our case, then you will see we need to basically build an index table first so that we know the positions, and then you just need to go back to look at every single word one by one, and to put them and count the number of times shown up, and then build a table like this. All right, so let's actually try that process. Okay, so but remember this little simple example called a vectorizer or count vectorizer. That's the simplest way to do this one, but it works. Okay. All right. So coming back to the code. All right. So let's try to handle this. Okay. So what we really need to do is convert this input data into something using count vectorizer. Okay. In order to do that, well, we since we already have all the sentences, what we really need to do is just to split them and then throw them into some kind of library to do it. You can always just write your own algorithm, but we can just also call the libraries. Okay, so what we will do here is this. Okay, so I'm going to reprocess the data. Okay, process the input data using count vectorizer. Okay, so they will pop up those ones. But I think what we need to do first is that we need to kind of split those into words. Okay, so I'm going to do this one. Okay, for each data row in the input data. Okay, so I'm going to get all the words list. So this one should be the data row dot split based on the space. Okay, split them into listed rows, and then you add it back. I think that's what the count vectorizer is taking to. Okay, so and then I'm going to create a new one. So I will call this one as the input data processed. Okay, and then the input data process is going to add those, and I'm going to print it. Okay, so I'm going to comment this one first. Let's just see the process. Okay, so before it, It's input data. And after that, we process, we'll see what the data looks like. Okay, so I'm going to run the code. And split. Oh, yeah. So that should be the, because yeah, they're trying to read the first one. We only have one thing in the string, so we need to add the first index. All right, so this is what the data looks like before. It's a list of a list. Every item in the list just has one thing, which is a full string. But now we split them, just break them down into words. Okay, that's all what we do. Because once you know this one, then you send it to the vectorizer, and probably can see how they can handle that directly. Okay, so as some of the AI already pops up, the thing we're trying to do here is something called a like from the Scikit-learn library, they already have this count vectorizer. Okay, so instead of just having the AI to write it, I want to just show a simple example of using count vectorizer in Scikit-learn. All right, I just see an example instead of having them to change it. Okay, well maybe they're trying to change it, but um, let's see if they can give us like a very simple example first. All right, so we don't want to change. Okay, don't change my code. Just show a hello world example here. All right, so they create a new file here to show the example. So let's see the new file. And yeah, so this is not too long, so very good. Let's go through this one very quick. And they create a hello world example. So they have same thing, text, three items here, and they build a count vectorizer. They just send the whole thing into the function, and then they will be able to get it. Okay. Yeah, looks like you don't really need to split the word. I thought we need to split the word, but it turned out we don't need it. Okay, so just give the whole like strings and then throw them there, and then you call this thing called a fit transform, and then you should be able to get the final results. Okay, well, let's give it a shot. Okay, so I need to make one change. So um, we don't really need to split it. All we need to do is just add that word. Okay, so data row, add the whole thing. All right, let me run it again. All right, so that's what we need, because previously it was a list of a list. Okay, now I just turn that into a whole list with everything inside, because that looks like that's what the input is going to take. All right, so we're going to follow here. We're going to get it, import. So everything coming from Scikit-learn. It's a very powerful library. The count vectorizer is there. And then once we have this, we're going to call this one here. Look at the example. Create instance, count vectorizer. And that's what you do. Okay, so it's called a vectorizer dot transform. It's called a fit transform. Yeah, fit transform. All right, and then use the processed input data. Okay, so I'm going to call this one as input data vectorized. All right, so hopefully this will do the job. All right. After that, we want to print it. Okay, let's see if we can even see anything. Sometimes we have to print something else to see something meaningful. All right, very good. Looks like some results here. Let's actually go through this output. Okay, the code are very simple. Make sure you understand all the process going on. This was the original data. Okay, input data, a list of lists. Because normally when we handle the problem, we just use that format. But for the vectorizer, they just need one list. So we put everything into one list and then put every synthesis. Then you can start to see that they're going to break down the whole thing. They vectorize it. And, you know, based on this, you can see for every words, okay, they, so if you look at this kind of array, we can probably just guess, because there is a 1, 0, 1, 2, 3, 4. That probably represents the input data, right? So for example, the last sentence has a Poly Pomona has strong signs. So there are 6 words. That's why this one has to represent that last sentence. Okay. So I love to read the 4 words. So the first one, no, that's not how it works. Okay, let's see. Or maybe they use different this one has 5 words. It looks like this one and this one. I think it's related. They might just get rid of some of the simple words like I. Okay, that's my guess. Okay, but probably as you can see, this representation just shows for every sentence, and then what are the words index and how many times that shows up. All right. So let's go back to this example. I think they print something else. Okay. First of all, you could look at the vocabulary. That's how you can find all the vocabularies. Let's try this to help us understand. Once you train the model, okay, you can just get all the feature names. Okay, let's see what this one will tell us. All right, vocabulary, you can see and bronchial fox has interesting is, so they pick up all the words and break them down. So that's why I remember they pretty much ignore some of the simple words like I, okay? Maybe other words like simple one, I don't know what they ignore, but there has some rules that they just don't count it because it's not very meaningful. All right, so that's the vocabulary, that's probably the index, okay? And then you can also look at the count matrix. So this is a better way to understand it. So let's try to run this. Oh, it's not X. It's actually the vectorized. All right. So here, guys, very important. Okay, so this one is much more clear. Compared with the one I just showed you, this is the final table. This is what's being calculated, right? So let's try to understand the first one. The first sentence has, they indicate 3 words right here, here, and here, right? So if you count the index, this is 0, 1, 2, 3, 4, 5, 6, 7, 8. So the index 8, if you look at the vocabulary, 0, 1, 2, 3, 4, 5, 7, 8. Learning. Okay, is that what we're trying to do here? Not really. Um, no. This is sorry, I counted wrong. 0, 1, 2, 3, 4, 5, 6, 7, and 8. 8 is love, right? So that's what this first word is. Once again, they ignore the I, so that's how you represent the first input. And then clearly this is 2, and finally is the read, right? The read is the last one, and oh, never mind. So the last one is 2. So they didn't really do the order, but then they just build the whole order based on this vocabulary. But the point is that seeing this matrix here, you can find the words in every sentence that showing up and how many times. Let's say if I change this one a little bit, okay, I do a fox and fox. You will see here in the second sentence, certain words become 3 times. Okay, let's try that. If I run that, and as you can see, this word here shows up 3 times. And that's 0, 1, 2, 3. That's fox. Okay, so that's count vectorizer. And you can also see it looks like different times the words may show up different sequence, but it doesn't matter. That's how the algorithm they will handle that for us. Okay, I'll go back. All right, try to run this one more time. And now you have this very clean, nice table. All right, and then the really nice thing here, you can see it is also a list of a list. That's exactly what we need to train a machine learning model. Okay, so they handle everything for us. All right, so the count vectorizer. This algorithm shouldn't be too difficult to write. If you think about that as a coding question, you take all the words, build the index, and then you go through all the words and then try to build the that 2D array. Shouldn't be too bad. Okay, but anyway, they have a library here for us to use. And with that, let's try to see if we can fit everything here into the model. Instead of using the input data, we're going to use input data vectorized, okay? And then this one, I'm not sure, we might need to use, I don't, I don't know if we can send this one directly. Okay, let's try to send it first. Okay, if it doesn't work, we'll try it different ways. So let me try to run to fit it. All right, looks like it's working. So it's just that whole format. So the list of lists just works for the fit. Okay, and then we can try to predict. But then don't forget, if you just do the prediction like this, all right, it's still not gonna work. Okay, let's try this. Because they don't know how to handle this one. Okay, you got a model trained, but don't forget you were training the model based on all this kind of format. Now you send me another sentence, they still don't know how to do it. So you have to do exactly the same thing to turn this into a count vectorizer, based kind of input. You still need to turn this into the numbers. Okay, so that's why now here you just need to do the extra step that for all the input you're trying to handle, well, you still need to use, we'll try this, okay, vectorizer dot fit transform. You just put everything here. All right, and then this time I will just simplify it. I will just put the two sentences into a list. All right, so that way we could just handle this two directly. And then they are going to produce two tables, one table with a 2D array. And for the number, hopefully this one form the right format for us. Maybe it's not right because this is 2D. Well, let's try to run it, okay? Just run it. Yeah, so it doesn't work because we are looking for the input data is expecting 21 features, but this one had only 7. Oh, that means we actually need to use this one here. We are using the same thing. No, I think when we do this. All right. So anyway, I'll just go back to look at the sample code. Okay, so how do we do those? Okay, so here is called transform. All right, run this one. All right, so this one works. We'll come back to explain this one, but it looks like the fit transform and transform. Let me just ask, okay, what is the difference between fit transform and transform from count vectorizer? All right, so training use fit and testing use transform. I think at the end they just all put a different kind of format. That's easier for you to input those. Okay, I just didn't dig into the data structures because for the prediction they use certain type of a list. Obviously, this transform actually works better for the testing, and then this one just give you the right input for the fitting. Okay, so that's probably the difference. Okay, so we don't need to dig too much about the detail. It's just a matter of data structure. But if you look at results, we predict here. I love to read books, and then the quick brown fox jump. Yeah, so that's the right results. But clearly, these two sentences because they are showing in our training data set. So it's not surprising they can get the results, right? So if we do this Poly Pomona, I think that we can also get some kind of results, right? So if we run this one, the science majors, right? I guess even if you miss some of the words, right? So they should still be able to predict it, yeah, because it's very closely related with that input data. So it doesn't have to be exactly the same thing. So that's when you can see the machine learning is trying to make some kind of predictions. All right. So this example is super simple, right? But it really shows one way to make a language model that you can predict next words. Okay. Later on, try to run and build this one yourself, because that whole process, understand how do you take the input data, reformat it, run the training, run the prediction. That whole mindset is very important. Okay, as I mentioned before, we never expect you to understand how the real language model works because nobody knows. But then you need to know as a CS major, how do you, what are the major steps, and then what are the major technique you need to do. In the professional world, they don't use this simple like a count vectorizer. Also, they don't look at things just like a sequence like here. I split the last word because there's so many different things. If you want to do this way, if I give you a large article, you need to split this one for many, many tables. Okay, so some of you probably already know that the professional language model, they use something called attention. Okay, there's a very famous paper called Attention is All You Need, right? So they basically look at the whole sentence together to find out the correlation between each word and the context. So they don't really do this approach. However, this one is a one type of language model. I think really shows the idea. Okay, not too difficult. But then here, the key new concept you should actually pick up today is the vectorizer. Okay, so in this document, I summarized all the different kind of common vectorizers. I'll put the link already in the syllabus. Okay, so this pretty much shows the same thing. And then there's all different type of vectorizers. So we can look at some of those. Like the first one is called this TF-IDF. So term frequency, inverse document frequency. Okay, so a very complicated name, but it shows something really simple. So it assigns weights to each term based on the relevance of the document and corpus. And the vectorizer capture the importance term of terms in the document. So they want to look at which term is more important. Okay, that's what this vectorizer is trying to do. I put some of the explanation here. So as you can see, like here, so let's see what it means. Okay, TF, term frequency, that represents the frequency of a word in the document. Pretty easy to understand, frequency. Okay, it measures how often a word appears within a certain top document. The higher the count is, the more important a word may seem in that document. Okay, so based on the frequency. Okay, so the total count and total number of words, and you divide it together, that's a frequency. And the inverse document frequency is that the significance of word in the corpus of multiple documents. It helps to identify words that are unique or rarely occurring across the entire corpus. So what happened here is that they eventually do some kind of inverse frequency. So their theory is that you don't want to only look at the words that shows the high frequency, because if you look at that one, it's always going to be the word like I, you, is, the, this kind of words. Very often, this kind of word doesn't give you anything. You actually want to pay attention to the word that doesn't show that often. Okay, very likely some of these nouns and special places, names, that actually is more meaningful. So this is going to try to use the frequency to determine the ones you don't see very often, and then use that information to vectorize every sentence. Okay, yeah. So here they show the very concrete example. I'm not going to read this one. You can take a look at it, but the same approach. Okay, giving every sentence, we build some kind of index, we count, we do the frequency, and then we use some of the very simple math to give an eventual number to represent it. Okay, so if you want to use the TF-IDF vectorizer, pretty simple. Okay, so you just need to import it. All right, and then we can just change it here. All right, so let me just yeah, comment this one here, and the rest will remain the same. Okay, so let's try to run this one. All right, as you can see, this time the table is quite different, okay, because they use the frequency to represent it. So it's just different ways of representing um, the strings and the text. All right, and then the results the same thing. All right, but there are a lot of other vectorizers. Okay, there are hashing, pretty straightforward. Somehow we hash the value based on the string. That's also very straightforward to think. And where to vector. And a very important one you might want to pay attention later on is something called a BERT vectorizer. So BERT is a very famous language model. So they are some of the backbones to build the GPT or GPT-2, GPT-1. As you can see, there are already something called a transformer-based language model. So this one actually use different kind of approach. They train the whole thing already based on the kind of context information I briefly mentioned before. So this one is very close to the language model we're using today. So we'll spend some time to look at the attention, the transformer stuff. Okay, so but here just you know that one important thing to handle for the language model is how do you process all the text and turn them into numbers. Obviously, the more efficient you can process those, the better. It's faster. It takes less space. All of those things matters. Okay. All right. So that's the vectorizers. The last one I want to show you is something about randomness. Because if you think about you use ChatGPT, okay, you get input, you got answer, and the answer always is different. Okay, the idea might be the same, but the way to present the answer always varies. In fact, you cannot really duplicate the same answer for most cases, right? So that means as you use the machine learning, there are some kind of randomness, and that's proved to be really good. You can use that one to get different ideas, different options. Obviously, there are so many different ways to do the randomness. And here, I just want to show you one way that because as you do the prediction, okay, right now, everything we do here is we just predict and then they tell us the words. But what really happened here is that when you predict something to call the prediction, the machine learning model is trying to predict the uh, probability of every single label. Again, this is a classification problem. So there are total of 5 choices. And once you call the prediction, they're gonna know, okay, for this one, the chance is 20%. This one is 10%. Okay, 10%, 10%. And this one has highest, maybe it's 50%. And then the prediction is going to automatically pick the highest probability and show it to you. So that's what this function is trying to do, the predict. Okay, but if you actually want to see the probability, you can actually see that. So here, um, as I showed you, this one gives you the probability. So let me do this. Oh, wait, so let's try to show you this one. I'll move this one here. Oh, it's just create a test data. Okay. All right. So test data. All right. So before we are printing the final result, I also want you to see the probabilities. So print probabilities. And then if we run this, let's check out the results. Wait, we don't have this one? Oh, we got to turn this proper attributes, okay? Probability to be true. All right. As you can see, this is the same result we're getting from the 3 input, but then here it shows the probability for each one of them. But this one only shows one. Oh, actually, I need to show all of them. Okay. All right. So probability for the first one that you can see, because we have 5 labels or class to pick. So they're representing the probability for each one of them. And then the highest one, they're a little bit equal, but obviously there is still a one that has the highest, which is probably this one. Okay. and then based on that index, they're gonna pick the word. Okay. And then some of this one, they're all very like equal, okay. But yeah, so there are still some changes. So they just pick the highest one um based on that prediction. All right. So you can always say that instead of just using the highest one, I want some randomness. So you can always say, well, based on this probability, you can pick words from the list based on the probability. So to do that, you can make a very simple like a random choice function. Okay. All right. So we um, provide all the labels, we'll give you the probabilities, and then you just choose one. Okay. And then you're going to use that numpy function. All right. And then finally, we predict the randomly choose one. Okay. Oh, this one, I'm sure we did more. Okay. So random choice, probability, we just did one. The P must be one dimensional. Uh, yeah. Yeah, we need to do that one by one. Okay, let's see that here. I just want to do the first one. All right. So the first time we only dealing with the first output. Okay, so initially with a book, but now you predict it to be major. If I run this every time, it could be different. At this time, it pretty jumps. What it's giving is based on this probability, and then we randomly choose the item from the list based on that the probability. This is just one way to simulate it. Okay. Once again, I'm not saying that they are using the same approach here, but there is one step at the end that gives you that randomness. Okay. So till now, this example, I think, really gave you a full set of feeling. Okay. I can only say it's just an initial like impression how the language model works. It's super, super simple, but it covers all these major steps. Okay. To recap, okay. Provide input data, knowing what you want to predict. Most important thing is knowing how to process all the text into embeddings and encodings with numbers so that you can throw those into the regular machine learning model. Okay, once you have the model, then you can start to predict. Don't forget you have to transform the input and get the data. If you want to bring some different kind of randomness, you can design your own algorithm to do it. All right. So that's all we want to show you today. All right. Um, so, um, but as I mentioned, if you want to dig into more on this one, the vectorizer has a lot of techniques. And also the training, we are still just using very basic machine learning training model like SVM. In reality, they build neural networks, okay, which is just basic, much more complicated, more advanced model that takes more computational power. We can also talk about those one next week. And then another thing is, yeah, the vectorizer, if you want to go deeper, the direction related with transformer. Okay, so that's the one being used today. All right. So I'm gonna stop here, guys. The example here, I want you to take it. So the links, I already put it into the syllabus. Okay, that's the code link, and that's the slides I used. I did give assignment today earlier. Not very difficult assignment. I just want you to use all the machine learning you have learned so far to find one specific problem to solve, and provide data, define a problem, and then pick a model to train it. It could be a regression problem. It could be a classification problem. Just pick something on your own. Okay, define a problem, follow the 5 steps I mentioned here, and then try to build it. All right. So these steps. Okay. Uh, Turn that into a table, show that in the code. When you submit, put your code into GitHub and send me a link. Okay. Just make the repo public. All right. So that's what we need for the assignment. All right. Any questions? Yeah, so you don't need to use both. Just you can pick anything, either regression or the classification. Yeah. Uh, in the past, I just did a regression. I think I was changing it. All right. Yeah, I will still just do some comparison. Okay, so the point here, if you define a problem, you can treat different kind of algorithms models to run it, right? So like the traffic example, we showed you how do you do the linear regression. Going back here, we got a linear model. We also have a polynomial model, right? So for the same problem, you should try to use at least two models, try to train it to see the difference between the results. Okay, to see which one is better. All right. Sounds good. Okay. This week definitely start work on this one. Okay. So the code, as you can see, all this is pretty short. Okay. But understand the process and then find the problem you have and model it. It's very important. Okay. Next week we'll dive into a little bit more on this language model to try to learn some of the more modern ways of doing the vectorization and some other things. Okay. All right. Stop this one.